Hello, in this video you'll be introduced to complex numbers. Complex numbers are a new system of numbers that involves a real part and an imaginary part. The real part is the part that is not coefficient to the letter I. Think of it like unlike terms. These two are not like terms, and therefore they cannot be simplified together. They must stay apart. So the real part here will be 5. The imaginary part is the coefficient of I, which is -3. So you've got to keep an eye out for negative coefficients as well. So we'll write the notation for writing the real part of a complex number z will be real, re, bracket z, and that will be 5. And imaginary part will be im, bracket z, and that will be -3. Now, for example, real numbers could be, let's say, 5, 8, pi, or even e. These are all real numbers that we're familiar with. Now, these numbers are part of the complex number field. In simpler terms, these numbers are still complex numbers where the imaginary part is simply 0. On the other hand, if we're talking about purely imaginary numbers, we're talking about numbers such as 5i, 8i, or even pi. And in these situations, it's the real part that is 0. You'll be asked questions in the HC involving purely imaginary numbers, and this is the response that this is the rule that you'll follow whenever you encounter purely imaginary complex numbers. So just to repeat, these are all still complex numbers, but they're certain special kinds of complex numbers: purely real numbers and purely imaginary numbers. Now, complex numbers follow the same rules for addition and subtraction as your normal algebra. Just treat I as if it was another prenumeral. But for multiplication, you'll have to know how to interact with multiple i's being timed together. For example, let's just say if we wanted to multiply 1 plus I by 5 plus 3i. Now, according to the FOIL method, we will go like so. And expanding this, we're going to have 1 times 5, which gives us 5. Let's write that again. 5. And then 1 times 3i, which is just simply 3i. I times 5, which is 5i. And 3i squared. Now, one of the most important things about complex numbers is that I is actually defined as I squared equals to -1. So whenever you see I squared, it automatically translates to -1. So in this situation, we have 5 plus 8i minus 3, which is really 2 plus 8i. Now you might ask, well, if multiplication involves us dealing with different powers of I, then what do we do with division? Because with division, we can't simply say, well, let's just divide and leave it like that, like down here. And this is why we need to deal with this new concept of conjugates. Now, so far we're just going to deal with conjugates on a purely algebraic level. Let's say we have a complex number called z equals to 5 minus 3i. The conjugate is written as z bar, and it's simply the same real part, but the imaginary part of this complex number is plus 3 instead of -3. Now, just remember, the imaginary part is the coefficient of I. It doesn't include I. If we say plus 3i, that's an imaginary number, not an imaginary part. Okay, how is this going to be useful for us? Well, let's say we wanted to do this example of 1 plus I over 5 minus 3i, and the typical question will be asking you to express this in a simpler form, in a form where you don't have imaginary numbers on the bottom of the fraction, like that. So in order to do that, we must multiply the top and bottom of this fraction by the conjugate of the denominator. We've seen this before in surds, as well as in 2-unit mathematics. So we're simply going to start by doing this: 5 minus 3i. Multiply everything, the top and bottom, by 5 plus 3i, taking care to put everything in brackets. Expand the top. Now we've done that earlier already, so 2 plus 8i. On the bottom, what you'll notice that this is difference of squares, but interestingly enough, when you do 5 squared, it's 25, sure, but this part is going to actually be minus 9i squared. Now, as you get more and more used to this, you'll skip straight to the next line because you know when you do difference of squares with I in it, it actually becomes 25 plus 9, which is really 34. So 2 plus 8i all over 34. Now, just to say what the question asks for, we have expressed it in the form a plus bi, but just to spell it out, you'll have 2 over 34, and b is 8 over 34. To clean it up a bit, you can even say a is 1 over 17, and b is 4 over 17. Now, please try the questions attached at the end of this video, and enjoy.